We'll evaluate the integral x cubed times inverse tan of x by using technique of integration called integration by parts. By now you should know the formula for integration by parts. It's the integral of u dv equals to u times v minus the integral of v du. We let the unknown integral, the one we're evaluating, we'll call it the integral of u dv. One part will be u, the other part, the rest of it, will be dv. From there we find du and v and express our integral in terms of the right hand side of this formula and hope that the integral on the right is easier. So let's proceed to do that here. We're going to let u equal to inverse tangent of x, and the reason is if we let dv be inverse tangent, finding the antiderivative of inverse tangent will still have inverse tangent in it, and that would make things more complicated. So dv is going to be x cubed dx. The derivative of u du is 1 divided by 1 plus x squared. And v, we have some choices here. We know that it will be 1/4 x to the 4th. Now normally 99% of the time we don't add any constant at all because it would create more difficulty for us. But in this case, a constant will be very helpful, because if we don't add it, look what happens. This then integral will equal to u times v. So let's rewrite it. X cubed inverse tangent of x, that's our u dv integral. That's equal to u times v. With this u and this v, this is 1/4 x to the 4th times inverse tangent of x. So that's u times v, minus the integral of v du, which is 1/4 times integral x to the 4th divided by 1 plus x squared. Now at this point in Calculus 2, if you have not seen integration by partial fraction, this integral, the integral of v du, is difficult to evaluate. Substitution will not help us, so we're stuck. If we don't proceed and read on how to use that technique, we'll be stuck and cannot solve this problem until then. However, a slight change in the selection of v will be very, very helpful. So let me show you how to do that. The integral, again, I'm going to come back to x cubed inverse tangent of x. Still, u is going to be inverse tangent of x, with du being 1 divided by 1 plus x squared dx. But now dv, coming from x cubed, v will be 1/4 x to the 4th, and I'm going to pick a special constant of integration. I'm going to subtract 1/4. This is certainly possible because the derivative of v is x cubed. But now the reason I selected minus 1/4 is as follows. I'm going to factor 1/4. That leaves x to the 4th minus 1, which factors into x squared minus 1 times x squared plus 1, and it is that x squared plus 1 that will cancel the x squared plus 1 in the denominator that comes from du. So now with that selection, let's go back to our integral. Here it is, the integral of x cubed inverse tangent of x is equal to u times v. So v this time is 1/4 times x to the 4th minus 1 times u, which is inverse tangent of x, minus the integral of v du, and that is 1/4 times x squared minus 1 times x squared plus 1 divided by 1 plus x squared dx. As you can see, 1 plus x squared and x squared plus 1 are the same thing. They cancel, and so we're left with 1/4 x to the 4th minus 1 times inverse tangent of x minus 1/4 times the integral of x squared minus 1 dx. And this integral is solvable, very easy, and it's very little left to solve this problem. We have 1/4 x to the 4th minus 1 times inverse tangent of x minus 1/4 times 1/3 x cubed minus x. we can add then c at the very end. And let's simplify this. This is 1/4 x to the 4th minus 1 times inverse tangent of x plus or minus 1 over 12 x cubed plus 1 over 4x plus c. And that's the answer to that problem. Once in a while, going from dv to v, it's great to select a constant other than 0. For